All right, guys, just a quick video on a few of the questions that I left off when I did the work through. This is for the test review for volume. All right, number 14, it says the linear dimensions of a pentagonal prism are multiplied by 4/5. Quick reminder that similarity ratio is the same as a perimeter ratio, which is the same as a linear ratio. Those are all linear things. Similarity ratio can refer to lengths, widths, heights, the radius, the diameter, anything that you can measure with length. These are linear measurements, and they are 1 degree. Area ratio is a similarity ratio squared. It is measured with squares. It is 2 degrees. And finally, volume ratio is the similarity ratio cubed. It is measured with cubes, and it is 3 degrees. So if you have a 1 degree ratio, or in this case scale factor, right? What do you do to work with area? So if the similarity ratio is 4/5, or if the scale factor is 4/5, to work with area, the area ratio is the similarity ratio squared, which would be 4/5 squared. Got it. The volume ratio equals the similarity ratio cubed, which would be 4/5 cubed. Got it. Perfect. So that's all they're asking is what would you multiply by? You've got to remember these rules. It's going to affect us big time on the next problem. Here I gave you the areas. So the area ratio would be a ratio of the area, 784 over 576. I'm going to reduce that real quick, 784 over 576. And I get 49 over 36. Now remember that similarity ratio equals the area ratio squared. So how do I get the similarity ratio from this? How do I solve for this? Well, if I take the square root of both sides, if I take the square root of the if I take the square root of this, what is going on? I got that backwards. The area ratio is the similarity ratio squared. It's like, what is happening? So for this question, we know that the area ratio is 49 over 36. I know that that equals the similarity ratio squared. I need to take the square root of both sides. That's going to get me 7 over 6 equals the similarity ratio. So this time they provided us with the area. So think about this. If you have area, right, how do you go from 2 degrees back to 1 degree? You do a square root. Now we have to go back forward to 3 degrees. So the volume ratio equals the similarity ratio cubed, which would be 7 over 6 cubed, which I think is 343, but let me type it in, 343 over 216. Let me confirm that one as well. There you go. This is the ratio you have to use to work with volume, which we've mentioned a few times. So for this question, we are going to have our volume ratio, and then they tell us that the smaller pyramid has a volume of 1080. Well, I'm going to put that on bottom. 216 smaller. The smaller number goes on bottom. And then we cross multiply and solve. 343 times 1080. Oh, it's a big number. 370,440 equals 216x. Divide by 216. And I get x equals 1715. Woo! So we had to take area, convert it to similarity, take similarity, convert it to volume. That's what we had to do on that question. All right, one more, a graphing one. This is a real fun one. It says find the volume of the solid if you rotate the bounded region for the following functions around the x-axis. So let's get this graphed. I'm going to start with the horizontal and vertical lines. Remember hoi vux. Hoi vux. Horizontal for y equals, vertical for x equals. So y equals -3 is a line at -3. So that's y equals -3. We got it. Then we have x equals 0. Well, x equals 0 is the y-axis. That's a vertical line. Vux, vertical. Vux is vertical. Vux is vertical, my friends. And then we have we have 3/5 x minus 6. So we start at -6, and we go up 1, 2, 3, 1, 2, 3, 4, 5. And that's where we're going to land. So actually, I only care about this part. So it has to be the section bounded by all 3 lines. So this is the shape that we are rotating around the x-axis. So that's what it looks like. I'm going to get rid of the extra. All I care about is the bounded region, which is that blue triangle. So then what are the rules here? We reflect it and connect it. We're reflecting it around the x-axis, and it needs to go all the way up to +3 when you reflect it. So there's the reflection across the x-axis. Now we connect it. We connect the outside vertices. We connect the inside vertices, which would be, hard to see. We connect inside vertices up there. And this is an interesting figure. This space right here was empty. So when you spin it around, this is all empty. Out on the edges, solid and solid. So this is a frustum with a cylinder cut out. So our volume is going to be the volume of the frustum minus the volume of the cylinder. We're going to start with the frustum. Every frustum, we draw this right triangle with a bar. This represents little radius, big radius, and height of the frustum. We need to get those numbers. So looking at this shape, it's kind of messy, I know. But the big radius, let's use an easier to see color. The big radius would be this number, 6. And the small radius would be this number, 3. So those are the radii of the big base, 6, and the small base, 3. And then the height of this frustum right here is 5. So this number, the height of the frustum is 5, and we need this spot. Please keep in mind, what do these things represent? Remember that if you were to keep this going somewhere out here, it creates a cone. We are getting the volume of this entire cone, and then we are subtracting this cone on the top. So we need the height and radius of the big cone. We need the height and radius of the small cone. We never actually directly work on the frustum. So we're going to work on the cones. This represents the big cone, and the triangle on the top represents the small cone. So we have to do height over radius of the small cone equals height over radius of the big cone. Now you could reduce, but I know that kind of confuses some of us, but the 3 and the 6 reduced to 1/2. You could do that. I'm just going to multiply as is just so we can practice one thing. When you distribute there, it has to be 3x plus 15. Has to. We have to distribute the 3x correctly. That's a big place people mess up. So then we get 3x equals 15, so x equals 5. So this is 5. So what are the pieces? So let's look at big cone. Big cone has a height of 10. So the volume of the big cone, 1/3 pi times radius of 6 times a height of 10. That's the big cone minus 1/3 pi, little radius and little height. Oh, don't forget to square that. We're doing big cone minus small cone. This is really important, guys. This 5 never shows up by itself. In our proportion, it's x plus 5. And our volume, it's 5 plus 5. That 5 never shows up by itself. We never work on the frustum directly. So this spot should never show up by itself anywhere. You've got to be really careful with that. So when you multiply this out, 3612, this will be 120 pi, 9, 3, 15 pi. So this is 105 pi. And if it was just a frustum, we would be done. But let's do a little side quest on the cylinder. Volume of a cylinder is pi r squared h. And if we look at just the cylinder portion, just this inside cylinder, that radius is 3 and that height is 5. So pi times 3 squared times 5 would be 45 pi. So the final answer is 105 pi minus 45 pi, frustum minus cylinder. 60 pi is what's left over at the end of the day. So there's a lot of good work there. There's a lot of things you got to be able to do. But there's the last few questions. We're going to do some good work. All right, I'll see you.